Well, hello. This is my demonstration of UAV subsystem and in a different environment. There's a terrain, and this is the hills of North Carolina, and I also have a runway. This is the cooking mess. So whenever I hit an object, it experiences a reaction force. So I have a cloud. I got this from the online generator, and I have randomized its position, its direction, its movement. So it's not quite easier to predict its geometry. So I need to get some algorithm right. First of all, I need to cast a ray towards its direction, and if I get any hit to it, I'll get most of the information on the left side of my screen. So I didn't find any hit. Let's try from different direction. If I shoot from this direction, there's a lot of mathematics been going in the back end, so it's taking a little bit more time than expected. But if I get any hit, then I'll demonstrate the working of ray tracing algorithms. So we are good now. And the cloud is above 1000. So it's giving me the real time height of the cloud. So I'd like to demonstrate the interesting thing happening here is called ray tracing. I'll just show the basic of it, how it works in this project. So at first I'd like to show the position of the light in the game. Sorry, in the code. The light is at 0, comma 0, comma 2000. It's at 0, comma 0, comma 2000. It means that the cloud is above the cloud, maybe above the cloud. Yeah, it's the position was 1686.01. So it is clear that the light is above the cloud. So it means that the lower face must be dim, not be brighter. So I colored these skins with a darker color. Since these two objects are same, so when one got hit, other was also change the color. So I like to demonstrate how this thing work. First of all, I was I was there in that position. I shooted the ray from that position, and whenever I got hit in this cloud here, it was here due to the random motion. It shifted in that distance. So I got my intersection point here, and from that point, what happened is that the two rays were automatically created, this ray and this ray. These two ray were automatically created. The smaller one, the smaller one ray is the normal of from the hit point, and the other ray, the longer one, is the ray from the hit point to the location of the light. So the angle between the normal and the ray to the location of the light is phi. And when we do the dot product between the smaller and the larger rays, and we can find whether the object is towards its face is towards the light or away from light. So in this case, the point where I got intersection was away from light. So since I had to do with all the meshes, but I only did the nearest point, and I shaded the entire object based on the nearer point. So these two clouds were darker due to the ray tracing algorithm, and others are in default because they have not been tested yet. So this is the ray tracing algorithm. So there are many more in this project I'd like to showcase again. So I'd like to go a little bit below, and I can also cast the ray in the ground and get the distance in the ground. So whenever I cast the ray again upward direction, if I get any hit, I'll go for finding the speed of the cloud. I need to find, yeah, I got the hit from there. So I can move back again. So it was this point I got the hit, but I may not get the hit again because it's in the random motion. If I get the hit again, let's see what happens. It's taking a little bit more time than expected. So cloud speed is 12.07. I again casted the ray up. Let's see what it gives. It's fluctuated to 168.16. Again, when I cast the ray up, again I got the plot of 42.06 here. So I'll just when I gather up all the data, I'll demonstrate the plot, the significance of this plot. So yeah, again got the another value, and the time I get the two magnitude and divide by the time I'll get the speed, and I need to find the displacement as well. So yeah, the speed is also fluctuating. It's not stable because I have randomized the cloud. I'm gathering the data first for my plot. It was 13.89. Again, I casted the ray. I can also make the cloud dynamic and with its own motion. If I have to find the speed, yeah, it can be a little bit more relative because it has its own speed. And if I move the drone as well, then there will be relativity, and maybe the measurement won't be that precise. But approximately maybe nearly same. Again, I should get the ray up, and let's see. Oh, we didn't get any hit point there. So now I got the hit point. I again casted the ray. I may get the both was in the motion. The drone as well, and the cloud is also in the motion too. So we'll get the speed, and if I get hit again, I got the speed of 80.85.45. So again casted the ray up. So this plot here is the steam. It's called steam plot. It is a plot of the plot I used from the IM plot. So I got 53.78 there. So the other information is saying just below the cloud speed is towards the UAV. It means that the cloud is coming from the direction up front to me. It means that is moving from front direction to back direction of the UAV. So suppose if I hit from the back direction, if I hit somewhere in the back direction, then it should say that it's going from back to first. So yeah, the information that we got in the plot is also important. The thing here is when the height of the cloud is at 1700, it says that the speed is there is a less speed, and the clouds at in the range of 1600 to 1400, 1600 to 1500, the speed is the speed is highly fluctuating from 10 around 10 to around 90. So as much we shoot the rays, the more data we gather, we can study in which height of the cloud, what the speed of the wind is, or what the speed of the cloud is. So this is about the cloud thing. Now moving forward in this project, the other important thing about this project is that the other most important thing about this project is that this There is a small camera here in front of the drone. This camera is keeping track of the drone in the center. This is the chase actor. This drone in the center of the sync is the chasing actor. I am chasing the drone from above, and I'm getting this display. And what happens is that this this system is the gateway to the computer vision of this project. For example, if we can capture the image of the terrain, so we can this is the surveillance system I have implemented. Like whenever I capture the image of the terrain, I get displayed in the ground station here. So this was the image of the ground station. So whenever I go towards the runway, and there was nothing in the terrain that interesting. If I go near to the runway, if I go near to it, yeah, there is runway in the display. So whenever I capture the image, there is runway. So the image is flipped between these two. These are just flipped image, but these are the same images. So so in the future improvement of this project, what I can do is that I can just train a model with different objects in the ground, and with implementation of computer vision, with the implementation of computer vision, I can detect the object, which object is in the terrain. So so yeah, I'm getting the images. All right, whatever there is in the terrain, and this is the real time image. Like whenever I capture, I get instantaneously. There is no delay. It's the real time image, and this is very important. This is the GUI rendering. I am rendering this image in the rows and column in a GUI. So so whatever object there is in the sync, I get same rendered in the ground station. So this is very important. And other thing about this project is that I can start the engine, give the ignition to it. I can stop the ignition, and there are some rotations, global X, Y, and G, and other things. And I can the another important thing about this project is that I can flip the camera and see where my clouds are, and I can capture the image, and I can detect the cloud as well. So if I had to implement the if I had to implement kind of object detection or edge detection of the cloud, this might also be the fruitful. So I can also again capture the thing above in the sky. I just flip the camera up. Well, now the other thing is that I can make the camera static. So yeah, this is I might be positioned static, and I can see the drone being flying there, and I can cast a ray in the terrain, and I can get where I'm flying the drone. So so there is a threshold point of I think 20. So if I go below the 20 range, I'll get the alarm that I'm not flying in the safe zone. So I must this is threshold. So I was not flying in the safe zone. The threshold was 20. So it notified the pilot that they were not flying the drone in the safe position. So this is also the safety system of UAV. It it demonstrates the safety system of the UAV. So it helps the drone to avoid the collision between with the terrain. So so the other thing is I want to showcase. So now I want to showcase the implementation of ray tracing and ray marching algorithm with a kind of shading thing. So at first, when I cast the ray in the scene, The ray is cast based on my camera viewport. Wherever my camera viewport was there, I defined this with a custom viewport. And if you can see there, there was intersection in this moon, and there was intersection in this moon. Intersection point was here with the in the back face. Yeah, it was here in the back face, and from this intersection point, what we did is that we threw a ray in the position of the camera was here, and we threw the next ray from this position to camera, and we also calculated the normal at that point, and this was the normal, and we did calculated the dot product between this ray, the ray towards the camera, and the normal ray, and we get and if that is greater than zero, then we provide the light to it. If you can see here, it is also demonstrated there in this cube. This small the small pink coming out of the box is the normal, and the ray that is going intersecting all the rays towards the light position. You can see the intersection point is the light position there, and this above is shiny, whereas the light below is darker. It means that the below is darker and above is shiny. This is the ray tracing algorithm. We trace the light based on the object's position, and whenever the object is in the position of light, we only give the ambient color to that, and we don't provide colors to that. This makes the scene more realistic, and rendering is a little bit optimized as well. So this is my demonstration of ray tracing. Now I like to demonstrate about the ray marching thing. So how it works. So I have four boxes there. So whenever I click the ray march algorithm, so what happened here is that first of all, the rays been transferred from camera viewport at the origin, and it calculated the sign distance among all the objects, and the nearest sign distance it traveled, the box up front, the box in the positive x direction was the first box it got rendered, and from that box again, the circle is shifted to another box in the left side of the first box, and from that box again it suited the sphere from that position to another box, and got intersection to another box, and from that box again the ray is suited and got intersection to another box. Well, from this position, if the object is very complex, the ray marching algorithm can go inside of it by searching the sign distance function, and with that function we can shade the objects based on the nearest position to the sign distance function. So this was all my demonstration. Thank you so much. Have a good time.